We're going to be talking about the Arduino programming language. If you need any reference, you can go to www.arduino.cc/reference/en. So under here they have their functions, different functions that you can call for the Arduino. And then there's variables. These are some of the constants they have. Conversion, data types, variable scopes, and qualifiers. And these are some of the utilities they have. Down here we have our control structure and the loop and setup, which we discussed in the previous video. And down here we have further syntax and a bunch of different operators for different things, which we'll get throughout the program. So we're going to start with an integer, which is int, is what you would type in for the integer. And on an Arduino Uno, it will yield negative 32,768 to plus 32,767. If you put unsigned in front of it, it will hold a value of 64,000 and change. I think you just add the left side to the right side. It's 2 to the power of 15 if you want to calculate it. On the Arduino Duo and other boards, as you can see here, it will yield negative 2 million to plus 2 million, and that's because that's a 4-byte system. I think it's a 64-bit system there versus a 32-bit. I'm not sure. I'm not familiar with those boards. Okay, so now we're going to open up this board here, or the blank sketch here, and we're going to create an integer. So int pin is equal to 13. So what we've done here is that pin, the name of the variable is pin, and the type of the variable is int. So you can only store those values that we discussed inside of this pin. If you tried to store, say, something at decimal point, it would kick an error, or it would just wouldn't store the decimal point. And then we set it to equal to, this is the assignment operator here, to pin 13. So we're going to take pin, copy it, and we're going to replace the LED built in. Now if you click upload to your sketch, to your Arduino, you'll see that the LED is blinking once a second. So now if you wanted to change, the beauty of the variable is if you wanted to change it to pin 6 and you had a resistor and an LED on pin 6, you just type pin 6, click upload, and now pin 6 is blinking. So that's the power of variables. There's manipulation and control statements that you can use with them, but we'll get into that at a later time. So now we're going to declare a constant. So constant int input Okay, so what we've done here is the same thing. We've declared an input pin of the type integer, but we made it constant, and we've assigned it a value of 6. Okay, so if we tried to change the value of the integer, or that input type here, it'll kick an error, and that's because the constant can't change in value later down in the code. It's a good way of coding stuff that you don't want to change. Okay, we're going to declare another constant. Now we're going to take this speed and put it in here. And upload that sketch. Now you'll see your LEDs blinking once or every half a second. If you change this to 250, you'll see that it's even blinking faster. And once again, that's the beauty of it. You don't have to type 250, 250. You just change it in one location. Now we're going to create a if statement. So what we've done here is if digital read input pin is equal to low, we're going to do what's inside these curly brackets. Otherwise, or else, we're going to do what's in these brackets here. So what we're going to do is we're going to set this to high. And we need to set the pin mode as input. Okay, so now if you upload this sketch to your Arduino and you put a jumper wire between pin 6 and ground, because if input pin is equal to digital read input pin is equal to low, it'll drive your LED high, and if you put pin 6 to 5 volts, it'll drive it low and the LED will go off. Okay, now we're going to introduce the serial monitor. So up here we go to Tools, Open Serial Monitor. I have it set up so it lays out real nice here. And you click Run or Upload. It'll print Hello World here, as you can see. Okay. Now that's really handy for debugging. You can output stuff if you have errors or you're looking for stuff. You'll see how you can use that later in the future. Now we're going to start with the function. Okay, so a function starts with void, because we're not returning any value. Void count int number. Okay, and now we're going to start with a for statement. Now I purposely made a mistake in here. Okay, so what this for loop is doing is it's initializing I to 0, and then as long as I is less than the number, it'll increase I on each rotation. So it'll print out I once each time. And if you click upload, you'll see what I mean. See, it counted the 0, 1, 2, 3, 4, and for some reason it didn't get 5. Well, the reason it didn't get 5 is because we need to be equal to the number 2. So if we go upload, now we've gotten all of them. Now, as you can see, this is a function count. So we're going to go back to our Arduino reference, and we're going to go to functions. So essentially this is their functions. Now the functions is something they wrote that you're calling. So when we go to digital read, this explains that it reads a value from a specific digital pin of either high or low, and its syntax is digital read pin. And if you go back to what I did over here, that's exactly what I did. Digital read input pin is equal to low. So you can use the function reference over there for your references. Okay, now we're going to discuss variable scope. So that's where variables are available in the program within other programs or within other functions. So right now we're going to access the pin variable. And if you upload that, you'll see that it's available within the setup function. It's also available anywhere in the program because it's a global variable is what we call it. So it would be available here and here. And you'll see that it prints out 13 on each loop of the for loop. Okay. So now we're going to delete that. And we're going to try and access the I variable. And you'll see if you try and compile this, it'll give you an error. And the reason it's giving you an error is because it's outside of the scope. So the easiest way to figure this all out is if you have a variable that's declared outside of the functions right at the beginning of the file, it is a global variable and accessible anywhere within the program. And then if you were to look at this little function here, number will be available anywhere within here, so you could access number there or inside of here. If we were to create int x equals 700, we'd be able to access x anywhere inside this for loop, but not outside of it. So we wouldn't be able to get it over here. And if we were to create an int z equals 700, we'd be able to access the z inside the for loop. So just always look for the nestation of the variables, and that's how you can tell what's available. Now we're going to create a new function. Count. So int a is equal to 500. A plus equals 500, which is just a fancy way of saying a equals a plus 500. Okay, but we're not going to use that because we got the shorthand here. So serial print line a. Now up here inside the nested loop, we're going to put count. So what it's going to do on each jump or loop of the for loop, it's going to jump down to count and execute this code, and then it's going to go back. So we're going to upload this, and I left a bug in here. And you'll see that it prints out 1,000 repeatedly. Now the reason it's doing that is because its initial int a is equal to 500. It's initializing a each time. If we put the static keyword in front of it, you'll see that you get a totally different result. Now all it's doing is, you can see it counts by 500 each time. So what static tells it to do is initialize a to 500 once, and only once in the lifetime of the program. So that way you can initialize a variable inside of count and change it, manipulate it, and not worry about it resetting each time. Another thing we need to discuss is volatile. So volatile variable int v is equal to 800. So what volatile is it specifically directs the compiler to load a variable from RAM and not from the storage register. So it's a fancy way of saying that it's faster access for the variable and that the compiler will not fix the variable. So if you're calling variables inside of interrupts or inside of timers, it's best to use volatile so that the compiler doesn't get mixed up. It just tells it that it's can be manipulated at any time. Okay, we're going to return to variables now. So we're going to get rid of some of the code we put in here because we don't need it. Okay, and we're going to return back to the reference. So there's reference of data types. These are all the different data types that you can have. We're just going to go through a couple of them. I don't want to go through all of them. Word is just a fancy way of saying unsigned integer, so it'll store a value of 0 to 65,535. An unsigned long will hold a larger value of 4 million and change, from 0 to 4 million and change if it's unsigned. An unsigned character is something we'll get into in a bit. There's a string, shorts. These are all kind of the same, so we'll skip them. The one thing you do need to be knowledgeable about, though, for instance, is the number of bytes it takes. So a byte takes 8 bits, so that's 1 byte of data. It'll store 0 to 255. I always recommend using the smallest amount that you can use, because it maximizes your storage. So if you only need to store a value of 255 and you know it's going to be between 0 and 255, use a byte instead of an int, because otherwise you're burning up memory. And on Arduino Uno, it's essential to save as much memory as you can. Doubles and floats. Floats will hold decimal places, and they are very precise, so they can store a lot of data for you. Double is very similar. And then we get into the booleans, which we'll explain in a minute, and arrays. So we'll go back to the code here. So we're going to start out with an unsigned int is equal to the maximum value. So if we go serial print line A, forgot to put an A up here. And you print that out to the serial monitor, you'll see that it prints out the value there. Now if we increase A by 1, which this operator here is just a simple way of saying A equals A plus 1. So we're going to upload this. Now this is where something interesting happens, and this is where a lot of bugs in programs come from. As you can see, we went above the value that it could store. So what happens is it rolls the binary off the board and it starts back off at 0. If I had added 5,000 to it, if I went A equals A plus 5,000, it would have, or 500, we'll use 500, it will equal to 500, or 499. See, that's where bugs can happen. You got to stay away from that. Okay. So now we're going to go to a boolean. So a boolean can either be true or false. There is no in between. So we're just going to get rid of this. And you'll see that what it prints to the screen is a number. And the reason it does that is because the compiler thinks of the number as either 1 or 0. So if this was equal to false, it would print a 0, as you can see. Now, so what we're going to do is replace in here for temporarily, if B is equal to false, and if we uploaded this file, you would see that it would drive the pin high because B is equal to false. If I put the not operator in here, which is B not equal to false, it wouldn't drive the pin high because it's not equal to false. It's equal to low. Now these are called comparators, and we'll discuss those in further detail later on. I don't want to get into too much about that. The other thing I want to cover is an array. So let's just go with a simple int C, open and close bracket, equals, in parentheses because I'm initializing it, okay. So what I've done here is I've created a array of C. So we're going to create a for loop to read them. And then the way you access it is a bit different. So you go C bracket I bracket. So that's how you access a array. You can't just go C because it won't know which one of these. This starts out at 0. So if you go in C0, you get 55, and so forth all the way down the line. So 0, 1, 2, 3, 4, 5. So if you notice me when I'm coding, oftentimes I start off at 0 instead of 1. It's because the language is based off of 0. Everything starts in 0 on a computer. Okay, I've cleaned up the code a little bit here. There's a couple other topics we want to discuss. So a character array is one. And you can print the character array out to the monitor just like this. And you'll see that that prints hello world in capital letters. Another one we want to discuss is a double. And we can print that out to the screen, and we can do arithmetic on it too. So in multiple, that this equals b. That's a short form for b equals b times 7. Okay. Now the last thing we want to discuss is a string. Now there's a number of different functions you can use on a string. To find things in a string, to cut off part of the string, to keep part of the string, turn it all to capital letters, and if you go to the Arduino reference, you should be able to find those functions in there. So we're just going to print this. We're just going to print this to the screen, and then we'll get into further details, maybe on string manipulation if somebody needs it later down the road. And that covers variables. Well, most of the variables. The rest you should be able to figure out just by reference from that sheet or that website. Okay, we're going to start discussing control statements, or control structure, and that's the area in here. And they're very critical to computer programming. You virtually use them for everything. So what we're going to do is we're going to clean up our code in here, because we don't need it. And we're going to put another statement here. So if we go else if digital read input pin equals high, it would do that. Else so what this says is that if the digital input pin is low, we'll blink the LED high. Otherwise, if it's high, we'll put the LED low. Otherwise, we'll just print out to the serial screen hello. Now we're never going to reach the serial screen because one of these two are going to be true. So it's just a matter of letting you know that you can put an else if statement in there. So now we're going to write a for loop, and we're going to do something a little bit different inside this for loop. So what we're going to do is we're going to print the value of I to the screen. But now we're going to put a test statement in here. If I is equal to 5, we're going to print I. Oh, sorry. So if we upload this, we'll turn on our serial monitor, and we upload this, you're going to see that it prints all the I's and then hello world when it hits 5 and carries on. If we were to put the word break in here, you will see that it stops, it jumps, it breaks out of the for loop. So it will only go to 5 and then it breaks out. So you can break outside of that for loop. You can also use that break for the do while or the while statements. The other thing you can do is type continue. I hardly ever use it, so I forget which way it's spelled. And you'll see a different result here. So what it does is it continues on to the next loop. Now you didn't see a difference here, and the reason being is we're going to copy this, I'm going to paste it here, we're going to hello world 2. And what's going to show you, you would think it would print hello world and hello world 2, but it's not going to print the hello world 2 because it's continuing. So it's jumping out of the statement and carrying on. Okay, so it's going on to the next thing. So we're going to get rid of that for loop, and we're going to put a while statement in. So we're going to create an integer, int I is equal to 0, while I is less than 10, I plus plus, and we can upload the sketch and it will print 0 to 10. And once again, if we put the break statement in there, you'll see that it stops at 3. And if I put the continue in there, it breaks out the same way as the for loop. Okay, now there's a do while statement, control statement. So it's do. Now the interesting difference, we're going to leave that do there. So the interesting difference between the do, we'll write it like this. You'll see that the while statement prints 0 to 10, and then the do while carries on. But the thing you need to understand here is that the while statement will only execute the code inside of here if the statement is true. So if it's true, this do while, if you were to set this to 10, which is the same as the other one, so it'll automatically condition as false, it'll still print I once. And that's because it executes the code before it calls the Y. So now we're going to go back to a switch statement. Okay, switch statement. So we're going to go switch, We're going to save the variable I. Case 10 and then colon serial dot print line break, because we need to break out of the switch statement. Case 11 Okay, so we're going to set I to 10 here. And when we execute this code, you'll see that it prints we are at 10. Now, that's because it's checking the variable I, and if it's equal to 10, then it executes the code in here, and then it calls break, which jumps it outside of the switch. If we set this to 11 and do the same thing, it won't do anything on the case 10 because it's not equal to 10. So it'll print we are at 11, and then it will break out. If it wasn't equal to any of them, it could do a default. So that's your default. Now it's not going to be equal to any of them, so it'll print the default out. So that's basically your control statements. They're pretty basic. One of the other things we do need to discuss is return. So we've discussed functions. So we're going to create a function count. So int count. Now, as you remember, I put void in before the count before. So we're going to int number for Okay, so we're going to get rid of all of this stuff up here so we don't get confused. So we're going to go int x is equal to count number. So if you were to load this right now, it's going to declare that there's an error, and that's because there's nothing returned for the scope. So what we're going to do is we're going to return I times I. So what the value, or number times number, because I is out of scope there. So whatever the number is, and we need to put a number in here. So say 5. So it will return 5 times 5. So if we go here and we go serial print line x and then upload all of this, I'll walk you through the code as to what it's doing. So it prints out, comes down here, goes through the for loop, prints out I for each time it goes through the loop, and then it returns the number times the number. So int x up here is equal to count. So that's how you get values returned from count. So you get the value of that, and then you can print it out to the screen. Okay, I've kind of written some code here so it's a bit quicker to go over. One of the things I wanted to discuss is reference for a function. So as you can see here, int a has been initialized to 5. and then we call function multiply a, and then we print the value out here. We're going to comment this out for a second. So when we do this, you're going to see that a is actually equal to 25, even though it was 5 up here. And the reason is we put the reference operator in front of the a here. So what it does is it's passing the actual address of the variable, so it's working on the actual variable rather than a copy. I do a lot of references when I'm coding. One of the main reasons is that it saves memory. Another reason is that it also you can work on the copies. The arithmetic operators down here are pretty basic. If equals int initialize a to 5 here, you can multiply a by 5, and then the shorthand is here. You can multiply a by a, which is right here. So you'll see that these two results will equal the same thing. So we'll just put that in there and we'll show you what I'm talking about. So we'll upload that. So you'll see that the a prints 25 and 25 twice. Okay. Now we can a plus 5 is equal to a plus equal a. A divided by 5 is equal to a divided equals a. Now there's a modulus operator, so we make b equal to 22, and then we go a is equal to b to the modulus of 7. So there's 7 goes into 22 3 times, and the remainder is 3. So that's what a modulus is. It leaves you with the remainder. So that's why we get a 1. Okay, now the shorthand for that is a. If you wanted to use just with the a, would be a modulus equals a. The other operators we need to be aware of is a plus plus, which increments a, and a minus which decrements a. Now up here, there's a couple other things that we should be aware of. With a for statement, if we go if true serial print line forever. And what you're going to see here is, because we're in the loop, which is just continuously repeating forever, it's going to just start printing forever like it's gone crazy as soon as it's done uploading. Now, if we put the logical not operator in front of it, you'll see that it stops. It doesn't print it. Okay. So now the other thing is we can put an end in here. So if we put end false and we were to hit this, nothing's going to happen. Now the reason nothing happens is because both conditions have to be true. So we'd have to do, if it's true on this side, it has to be true and false. So we can click on that. You'll see that it doesn't do it again because both conditions on both sides have to be true. So if we go true, it'll run because both sides are now true. So the other operator that we should be aware of is the OR operator. So if we put an OR operator in there, which is the pipes, and we put this one to false, and we upload it, it'll continue to print forever. And the reason is because if it's true or false, and one side's evaluating to true, so it doesn't matter what the other side's doing. So those are your Boolean operators. So if we go over to here and we go down here, these Boolean operators are right here that we were just discussing for the if statements. The arithmetic operators are here, so you can do arithmetic on anything. And then down here are the compound operators, which is the shorthand I was showing you. We're not going to get into bit hand operators yet, or the dereference operator or pointers. Okay. Now you can use comparison operators to compare anything within an if statement. So if you wanted to compare A, you could go A equals is not equal to B, A is less than B, A is less than or equal to, A is equal to B, A is greater than B, or A is greater than or less or equal to B. So that's your comparison operators. One of the other two things I want to do talk about here is there is some comments and some defines. So we're going to get rid of this statement here because it's creating an infinite loop of data that's printing out to the screen, and we're going to get rid of this. So if we wanted to, we could get rid of this altogether here, and we can change pin to define to a define statement. Now you're going to think it's just like a constant, but while it is, it's a bit different. So what it does is wherever it sees pin in the code, it substitutes the value of 13 directly into the pin when it compiles. So the compiler doesn't see a variable, it just sees 13, and it's that simple. Okay, I know it's a bit, maybe a little bit to get your head wrapped around that one, but that's what's happening there. The other one that you should be aware of is pound include. And what you can do here is you can include another file that you've written code in to bring it into this program. We'll get into that at a later date when we discuss classes and objects. But for now, let's just stick with this. Okay, I hope this video was helpful for you. If you have any questions or comments, please post them, and I will be more than happy to review them. And I appreciate everything, and thank you for your time.